Hi all, welcome back to my channel. Today, as part of our ongoing Must Do series, we will be attempting minimum platforms. So let's start with the problem description. Given arrival and departure times of all the trains that reach a railway station, find the minimum number of platforms required for the railway station so that no train is kept waiting. Consider that all the trains arrive on the same day and leave on the same day, which means the dates that you'll be getting, the time you'll be getting, it's for the same day, okay? There is no day 2, day 3. Okay, arrival and departure time can never be the same for a train, but we can have arrival time of one train equal to the departure time of one train. At any given instance of time, same platform cannot be used for both departure of a train and arrival of another train. In such cases, we need a different platform. What they mean by that is, let's say you have a train A, it can't simply come at 1800 and leave at 1800, right? That is not possible, the which is what they have stated as simply. Okay, and also next thing, if a train is coming at 1800 and leaving at 2000, and there's another train that's coming at 2000 and it's leaving at 2200, then you need two platforms for this. You can't simply say that, okay, when this train is leaving at 2000, I'll accommodate the next one. You can't do that. Okay, so basically in this case you need two platforms. Now we have a very beautiful example here. Let's start with it. Start understanding what it means. Okay, so we have, I think, 6 trains, and these are the arrival and departure times. Remember them that these are in order. Like this 0900 and 0910 is for train A, then 0940 and 1200 is for B. Okay, so yeah. Now let's. I mean, the answer is 3, but let's see how exactly did we arrive at answer 3. So I am now going to start, let's say, drawing platforms. Okay, I have a platform P1 that initially will be accommodating this train. Let's say, okay, let's call it train A, B, C, D, E, and F. Okay, so platform 1 will initially have train A. Okay, then the train A will leave at 0910. The next train B arrives at 0940, so I can again put it at platform 1. Okay, then the next train comes at 0950, but I can't use the platform P1. I need another platform, so I will accommodate it at platform P2. Okay, then another trains arrive at 1100, but both my platform P1 and P2 are busy. P1 will get freed at 1200 and P2 will get freed at 1120, but this train is arriving at 1100, so I need a new platform. So basically this will become my P3. Now the next train arrives at 1500, and by this time all my 3 platforms are free, both P1 P sorry all P2 P1 P2 and P3. So I'll accommodate this one at P1, and the next trains arrive at 1800. My P1 is busy, so I'll again accommodate this one as P2. Okay, so at the end of the day, only my 2 platforms are occupied, P1 and P2. Okay, so at the end of the day, how many platform did I used? What was the maximum number of platform I used? It was 3, right? And that was when the 4th train arrived. So my answer in this particular question is going to be 3 platforms. And yeah, that is what they have provided us here. Minimum 3 platforms are required to safely arrive and depart all the trains. One thing I would like to point out is that don't assume that this arrival time is always going to be a sorted manner, right? Nowhere in the question have they mentioned it specifically, right? So I would ask you to just prepare for the first scenario, and if you are, let's say, giving an interview, it will be a really great first question to clarify that the arrival time is in a sorted manner or not. Okay, so since it has not been mentioned in this question, I'm not going to assume it. So the next example that I will be taking is basically where the arrival and departure time are in a unsorted manner, and we will be forming a pseudocode there. Okay, so let's move on to a new example. Okay, so this is the example that we'll be using. In this example, we have 7 trains that will be coming, and these are their arrival and departure times. Okay, so initially what you'll be doing is you'll be sorting both of these arrival and departure arrays. Now the first question that will be coming to your mind is, won't they go out of order if I sort them? Because it is not necessary that the arrival and departure are going to be with the same variation that others are. Okay, so let's for example, let's say that this is train 5, right? It is coming at 12:10, it's leaving at 14:00, but in my sorted arrays it's coming at 12:10 and it's leaving at 15:00. So what is, won't that pose a problem? But I mean, it would have if the question was a bit different, if the question was asking us to give us the exact order and the platform which the train has occupied, but that is not what they're asking. They simply want us to tell them that how many minimum platforms are required. And in order to find out that, there's only one question that you need to solve. That is, before the arrival of the next train, has any train departed? Doesn't matter which train, but has any? That is the only question that you need to ask. Okay, so let me that is the one line that we'll be using to solve this whole problem. Okay, so let's try to solve this question using this line. Since we are going to compare the arrival and departure time, I think it makes sense to start the traversal of arrival array from the second train, and we will be comparing that with the departure of the first train only. Okay, I need some variable to store my answer, so that will be answer. Now let's start the comparison. Train 2 is coming at 0900, and then I ask, right now the platform occupied is 1. Okay, because the first train will be occupied a platform. Let me just write down 1, 2, 3, 4, 5, 6, and 7. Okay, so 0800, the train 2 comes at 0900, and then you ask, has any train left? So now, no, the departure time of the first train is 1100. That is much higher than train 2, so you need another platform to accommodate this train 2. Okay, the train 3 comes at you move your pointer a bit forward, you come to 1200. Then you see that arrival of train 3 is 1200. Has any train left before that? Yes, 1100 has left before that. So you decrease the number of platform occupied, and then you move this pointer a bit forward. You come at 1130. Remember, train 3 has not come yet. Okay, it has not actually arrived at platform. We are just checking the conditions right now. So the arrival of train 3 is at 1200. Has any train left yet? Yes, 11, the train 2 has a train has left at 1130. I said a train, not train 2. Okay, a train. I'm not sure which train it is. So yeah, right now the platform occupied is 00. Then we come and then we move this pointer a bit forward, we come to 1400. Okay, and then train 3 arrives. It arrives at 1200. So again, one platform is occupied, and then you compare this 1200 with 1400, and definitely it's going to be smaller, so you move it forward. You come at train you come at train 4. Train 4 will be arriving at 1210, and some train will be departing at 1400. So the arrival of train 4 is smaller than the departure time, so we need one more platform. Okay, and then you come and then you move your pointer forward, you come to train 5. So train 5 will be arriving at 1400, and yeah, a train will be departing at 1400, but remember, in that condition we need another platform. You can't use the same platform, right? So we need 3 platforms at this point of time. Okay, after that you again move your pointer a bit forward, you come to 1500. Train 6 will coming at 1500. Has any train left before that? Yeah, there is a train that is leaving at 1400. So your platforms occupied will become 2, and you move your departure pointer to a bit forward. Okay, 1500. So again, a train 6 will be arriving at 1500, and departure of a train is at again 1500. So in this case, again, you need one more platform. So you need 3 platforms. 3 platforms will be occupied, and you move your pointer a bit forward. You come to train 7. Train 7 will be arriving at 1830. Has any train left before that? Yes, train 4 would have left before that. So your answer will become 2. Actually, more than answer, it makes sense to have written it as platform. Okay, so platform occupied will become 2, and after that you move this pointer a bit forward. You compare again that train 7 will be arriving at 1830. Has any train left before that? Yes, 1500 has a train has left at 1500. Your platform will become 1. You say again, okay, train 7 will be arriving at 1830. Has any train left before that? Yes, a train has left at 1700. So your answer will become 0, and after that train 7 will arrive, and there is no need to compare further. Why? Because now if you have checked the arrival of all the arrays, you have your maximum, you have your answer, right? You don't need to just traverse through all the departure array. There is no need to do that. Most of the solutions do that, but there is no need. Okay, so yeah, we are done with this point. Now how do you find your answer? This was the occupancy of platform. So you just take the maximum of whatever it is, and you get your answer as 3. So for this particular question, your answer is going to be 3, right? I hope that makes sense. If you have any questions, do ask me in the comment section. I'll definitely try my best to answer them. Right now, what we are going to do is we are going to form a pseudocode for this. Right. So I'll be using. I'm just going to write the main conditions. Okay. After that, we'll move to the live coding. So let me use a pointer known as I to traverse the array, and departure will be traversed using j. Right, let's start with the pseudocode. So your I will be initialized with the value of 1, j will be initialized with the value of 0, current will be 1, current means the number of platform currently occupied, and this will be a fun answer. Let's say it's 0. The work of your answer is basically to find out the maximum of current. Okay, now what is going to be the logic for the pseudocode is you need a traversal of I from 1 to n. Okay, and after that let's form up the main logic. If the arrival of a train is greater than the departure of some other train, what does it mean? That let's say a train is coming at 0900, it's leaving at 1000, and the train is coming at 1200 and it's leaving at 1300. So you can see that the arrival of the next train is greater than the departure of the previous train. So in this case, basically a platform is going to be free up, right? A platform is going to free up, and you also need to move this pointer forward. This is going to be the case. So what do you write? You say that the current number of platform is going to free up, and let's move our j pointer forward. J basically means departure, right? Because why are moving j pointer forward? Because a train has left by that time, right? Otherwise, what is going to be a condition? Let's take an example. A train is coming at 0900, leaving at 1200, and the train is coming at 1100, it's leaving at 1300. In this case, when train 2 comes, train 1 has not left, right? So this is basically your else scenario. In this case, one more, my bad, yeah, one more platform is going to be occupied, so the total number of current platform will increase by 1, and you need to move your arrival pointer forward. Why do we move arrival pointer forward? Because no train has left by that time, right? So yeah, this is the complete pseudocode for this question. That is all, right? Now let me run this code through the compilers, and let's verify if this logic is complete or not. All right, let's start with the coding. So let's initialize the values. I equals to 1. Remember, is the point. I will be the traversal pointer of arrival array, and j will be traversal pointer of departure array. And then you need some value of current that will tell you how many values are occupied. So current will be 1, and answer, let's say initially it can be 0, though it also makes sense to be 1. Yep, with this we're done. And don't forget to sort the arrays, otherwise most of our test case will fail. Okay, so arrival dot sort, departure of sort. Now let's start with our logic. While I is less than n, this is going to be a condition. Okay, and what was while arrival of I is greater than departure of j. In this case, what do? We say that decrease the value of current by 1 and increase the value of j with 1. Otherwise, this is the same logic that we discussed earlier, right? Otherwise, current will increase by 1, which means a train is coming before a train has left, and I will increase a bit forward, which means no train has left yet. Okay, and at the end of the day, your answer is going to be max of answer comma current, and then you return your answer. Yep, that is this code we discussed. Now let's try to compile and run this. Yep, compilation completed. Correct answer. Now let's try to submit this. So all the test cases have passed, and yep, we have successfully solved this question. If, by the way, what is going to be the design compression? Let's think about that, right? So this is going to be an order of n. This is going to be an order of n. So can we say that this was solved in order of n? No, we can't, because the sorting method that we used, even the best one, gives you a time complexity of order of log n. So in completion, in the total time complexity of this question became n log n plus n, that comes down to n log n. So the time complexity of this question is n log n, and what is the space complexity? I mean, if I discard the sort because I don't know we are using quick or merge, so for now let's say that it is simply order of 1. Okay, so yeah, there you have it. This was the solution of minimum platforms. If you have liked this question, then do subscribe to my channel for more such questions. Thank you.